Thank you, Gordon, for the opportunity to present some of our research here. I will talk about glycan profiling also in relation to cardiometabolic disease risk. First, I have no disclosures. And since you put me into the precision medicine slot, I think, I wanted to talk about I'm more into precision health or precision prevention. So I think if we look into the complexity of lifestyles, I'm in the nutrition field, and the complexity of human population, it's clear that also for prevention we need more targeted approaches, especially if we see how effective prevention can be, if it's implemented effectively, and how much we struggle to implement it. For the precision health approaches, we definitely need biomarkers, and biomarkers that cover all relevant biological domains. And just talking about what we want from a precision health biomarker is really a relatively long list. So it's a precise assessment of the biological effects of lifestyle exposures. It's accurate prediction of prospective disease risk, and also we would like to have changes reflecting change in disease risk, and prediction of subgroup-specific responses to lifestyle interventions. And all that depends on really being able to measure all relevant biological domains. So I can, for glycan specifically, only report on the accurate prediction of prospective disease risk with glycan biomarkers. And I will basically summarize the results of two papers that we have published in the recent years, with one on total plasma protein and glycan profiling in relation to type 2 diabetes and cardiovascular disease incidence, and the other on IgG-specific glycosylation patterns and incidence of the same endpoints. So coming to the methods, we have worked with primarily with the EPIC-Potsdam study. EPIC-Potsdam is a population-based cohort study of over 27,000 participants. Most of them are apparently healthy at baseline, and then for the molecular phenotyping, we rely on a so-called case cohort design. That means we have a random subsample that is representative for the full cohort, plus all incident disease cases, in this case type 2 diabetes and cardiovascular diseases. When I talk about cardiovascular diseases here, pooling stroke and myocardial infarction. And we oversample these incident disease cases from the full cohort so that we have more statistical powers to relate biomarkers to these endpoints. And the Janus lab, both the total plasma and glycan profiles and the IgG glycan profiles were generated in these type 2 diabetes and cardiovascular disease case cohort. And now to the data analysis. So for type 2 diabetes, there were a little bit more cases, and we didn't expect and didn't see strong differences between men and women. So we could set up a classical training and validation design. So that means that we split the sample into a analytical training sample, which is 2/3 of the population, a random split, and discover glycan biomarkers and validate them internally in the validation sample that was not seen before in the biomarker discovery process. And for the statistical workflow, we first, because of the known nonlinear associations of glycan profiles with chronological age, we did nonlinear age adjustment and used the age-adjusted glycan residuals for biomarker discovery because we didn't want to simply rediscover age associations with the risk of diabetes or CVD incidence. Then we did the pre-selection step with the random survival forest, selecting the most important glycans for diabetes prediction, built a non-linear model where the glycan transformation were derived from multivariable fractional polynomials, and basically all this statistic to then arrive at a robust cross-validated score, glycan score, which we constructed by putting these partly transformed glycans into a Cox model and deriving beta estimates, and then multiplying each transformed glycan with the beta estimates and summing them up so that we have one variable that basically summarizes all the predictive information in that glycan profile in relation to type 2 diabetes incidence. And for the internal validation, we examined the predictive accuracy. You ask for that based on the area under the receiver operator curve and also the net reclassification improvement. We compared the performance with standard non-invasive and biomarker-based risk prediction models, and we combined the glycan score with the standard equations and checked if it improves the predictive accuracy. And we also had a relatively small external validation sample for this total plasma and glycan profiles in the FinRisk study. For CVD, it's a little bit, the sample was smaller, and we expected sex differences based on experiences from other biomarker panels, and actually also observed that the selected glycans were different between men and women. So we did a non-random sample split and analyzed men and women separately, and then didn't have the statistical power to have internal testing and validation settings. So this is really more like hypothesis generating results. So for CVD, it's a sex stratified single cohort analysis, age adjustment, machine learning selection, and nonlinear score building was done in the same way, but the testing of the model was done in the same sample. So the interpretation has to be a little bit more cautious. And then finally, that was the statistical approach for the analysis of the total plasma protein and glycan profiles. And now for the IgG glycans, we basically took a more etiological approach, looking into different adjusted models. Naturally, we also compared or looked if they further improve the diabetes and CVD prediction beyond total N-glycan protein profiling, which was not the case, but we still built scores and had the chance to externally validate them and get some idea of how much of the total N-glycan profile associations are attributable to IgG glycosylation. So to the results, I won't spend much time on the descriptive results, but just to mention, like as I said, the EPIC Potsdam is a population-based cohort. Participants are roughly between 35 and 65 years. Generally, like a relatively healthy population, but still a tendency towards like overweight and obesity. We saw that the correlation structures of the glycans with between men and women, cases and non-cases, were very stable. The correlation structures with like biomarkers of disease like lipids, CRP, and the like were also stable and in the expected direction. So like this, it seems to like show the associations that we expect from the literature. But more interestingly, the the novel results on type 2 diabetes prediction. So all this, like these several selection steps I'm showing here, where is the pointer? The association of the machine learning selected total plasma protein and glycans with type 2 diabetes in a mutually adjusted model. And we see very robust and significant associations and strong associations that, that was not my intention, that are similar between the discovery cohort, the training set, and the validation cohort. And if we summarize all these single glycans into glycan score for type 2 diabetes prediction, we see a very strong association. So that is the hazard ratio per standard deviation. So with each standard deviation higher glycan score, it's a 4-fold diabetes risk increase, and that is quite consistent in the internal validation cohort. If we look into the receiver operator curves, we see that the C index is already for glycans alone, without H, very strong. If we add H, like the information that we subtracted in the beginning, it's comparable to this non-invasive German diabetes risk score, which is a clinically applied diabetes risk prediction score. So very comparable in terms of predictive performance. And if we combine these biomarkers with the non-invasive diabetes risk prediction score, we see a further improvement in prediction. And the same is true for the combination of glycan-based biomarkers with glucose markers, that's blood glucose levels and HbA1c. Also, the glucose markers alone are a little bit stronger than the glycan score, but the combination adds additional information. And that is the net reclassification statistics. So every positive numbers means an improvement, and I think we have some suggestion that this improvement is mainly based on better classification of the cases. So these numbers are higher than those, meaning that the sensitivity of the risk prediction model is improved. And finally, to mention that the C index in the external validation sample was a little bit lower, 0.76, but that's still, I think, a very good indication that this is a robust association. So in a completely independent sample, the glycan score also strongly predicted diabetes risk. Sorry, how much time do we have? 2 minutes, okay. Then I will go quickly to that were the diabetes association, and this were the stronger results. We also saw associations of the glycans, of the total plasma protein glycans with CVD incidence, not as strongly in terms of where am I? Here. Prediction. So the prediction of glycans alone was more in the range between 0.6 and 0.7. And then the combination of glycans with the risk prediction score of the American Heart Association slightly improved the C index in women, not so in men. So these are different selected glycans. And but if we look into the net reclassification index, which is more sensitive for prediction improvements, we do see some indication that the sensitivity of the risk for incident type 2 diabetes cases is improved when when GP5, which was the selected glycan, is added to the AHA score, whereas for men the specificity is improved. So non-cases are more likely to be classified as non-cases if the total plasma protein glycans that were significantly associated with CVD incidence in men are added to the AHA score. And finally, the IgG glycan profiles, which there were some associations for type 2 diabetes, I jumped over that, but they didn't add a lot, but they were much weaker than for the total N-glycan proteins in comparison. For CVD, that was not the case. So it didn't add anything to the total plasma N-glycan prediction of CVD, or the association strength was not increased, but it's almost as strong, so that I think these comparative analysis indicate that much of the information in N-glycan profiles in relation to CVD risk is really due to IgG glycosylation patterns. So, I think for the conclusions, we saw very strong type 2 diabetes prediction with N-glycans alone, and additional predictive value if we combine them with standard risk markers. And for cardiovascular disease risk, compared with clinical risk prediction models, they don't, the results are not so clearly, although the NATRIC classification improvement suggests some improvement, so that I would say we still need more powerful analysis in relation to CVD risk. I just want to say that I'm presenting this on behalf of all the co-authors, many from Gordon's group, the others from the German Institute of Human Nutrition, and the funders can be found in the published papers. And much of the funding for the glycan measurements was also generated by Gordon's group. So thank you very much for the opportunity to present this here.